Welcome back, folks. So we did example number 2 on the previous video. We were required to determine the cos of 75. Then we noticed that the cos of 75 is actually the sum of two numbers, which is 45 and 80. And then we expand, and there's this additional formula for cos, then get this in the final answer we managed to obtain. So on example number 3, this is the example that is given to us. If the sin of A is equal to minus 3/5 and A is between 90 degrees and 270, and the cos of B is equal to minus 12/13, and B is between 180 and 360. Determine the value of sine A minus B. So the first step here is to identify the diagram where we must place this angle A. So the meaning of this restriction here is that angle A must be between 90 degrees and 270 degrees. This means that angle B must be between 180 degrees and 360 degrees. So diagram for number A is this one here. And diagram for number B is this. Diagram for cos B is this one. Diagram for sine A is this one. So we can see that our right angle triangle is exactly between 90 degrees and 270 degrees. And by definition, the sine is opposite over hypotenuse. That is why here we have the opposite, which is minus 3. And then we have hypotenuse, which is 5. Minus 4, we use Pythagoras theorem to calculate minus 4. So we obtain minus 4 by saying x squared is equal to r squared minus y squared. And then we take the square root on both sides, and we obtain minus 4. So this side, we observe that angle B must be between 180 degrees. Our diagram must be between 180 degrees and 360 degrees. Here's our diagram, is between 180 and 360, and by definition of cos, we have adjacent over hypotenuse. That's why here we have 13 as our hypotenuse. Here we have minus 12 as the adjacent, and the value for y was missing. We used Pythagoras theorem to calculate minus 5. Having said that, we will proceed. We expand. This is called the subtractional formula for sine. We expand it. We can also verify from the formula sheet the subtractional formula for sine. Then we must substitute this. The sine of A, we read this from the diagram. Cos of B, we read it from diagram, and cos of A, we read it from diagram, and sine of B, we read it from diagram. When we look at our diagram, we can look at cos B. The cos of B is given by the adjacent, which is minus 12, over hypotenuse, which is 13. That's why here we have minus 12 over 13. And the cos of A, we check the first diagram. Cos of A is minus 4 over 5, because minus 4 is the adjacent, and 5 is the hypotenuse. That's why I have 5 here over the square root of 13. Having said that, here we use multiplication, we get 36. Because we said 3 times 12, we get 36. Negative times negative is positive. Then 4 times 5 is 20, and 5 times 13 is 65. So here we see that the denominators are the same. We just write one of these numbers. So 36 minus 20, we get 16 out of 65. So that's a very interesting problem. Please write this problem down and practice it with me. If possible, I'll repeat this video even more than 2 times. So let me emphasize the major points. The first thing that we look at when we're given this type of problem is to know where must I put my diagram. This restriction will guide you, and this restriction will guide you. And then remember definition for sine and definition for cos. And the missing side, always use Pythagoras. Always use Pythagoras to find the missing side. Thank you very much for watching. Let's meet on the next example, which is example number 4.